Thanks for the chance to present, everyone. Looking forward to sharing some information about this, answering some questions. I do hope that this will be an interactive presentation because there's so much new stuff and I don't have a great feel for what people know and what they don't know. And so please feel free to jump in and ask questions. I got into this, I went down this rabbit hole about a year ago when I started working on a business involved in treasury management for corporations and optimizing yield. And in that process, discovered some of the DeFi opportunities out there where you can earn 800 to 1,000 basis points rather than the 20 to 30 basis points that you can get in something like a CD. And at that point, I realized that there's something much bigger going on and bigger fish to go after. And so I started building a business that has a significant Web3 component to it. So, so as the name would imply, there were two webs before this. And so to put those into large categories, Web 1 is generally considered to be what we knew in the 90s and 2000s, early 2000s as a read-only web. So it was just people put information out there online. There wasn't much interaction with it, but it was a good source for information. Web 2 added the dynamic of users contributing information back into the system. And so most notably, that was in the form of social media. And so that was really evolved the web into something that was participatory and also centralized. And so a lot of power went to some of these big companies that created network effects in their businesses. The Web 3 is where there are no intermediaries and it is decentralized. And it's really something that was only made possible with Ethereum and smart contracts and all of the things that have very quickly evolved out of those or from those things. So Web3, the resulting thing is really a collection of ideas and a collection of technologies. And the collection of ideas from a high level, this is my definition. So it's no intermediaries, and we'll talk about each of these and what they mean. Decentralized, it's an easy transfer of value, it's programmable money, and it's shared ownership. So we'll circle back on those, but first talk a little bit about the evolution of technologies that have made this possible. So first and foremost was cryptography, specifically a one-way hashing algorithm. And from the hashing algorithm came Satoshi's invention of well, before Satoshi was the invention of a blockchain, and we'll go into detail on what a blockchain is. But Satoshi Nakamoto, pseudonym for the inventor of Bitcoin, took those concepts and created the world's first digital currency, or at least effective one, called Bitcoin, that we all know. And from Bitcoin, that was further innovated by Vitalik Buterin to create Ethereum. And so it's on the shoulders of those giants that we're standing here today with an opportunity to innovate in the Web3 space. So I wanted to make this, as I said, interactive and a little bit fun. So if you've got your phone handy, you want to snap the QR code, or you just want to type in the URL, I want to jump to this because this helped me understand exactly what's going on some of the underlying technology. So if you go to that URL, you'll be taken to this page, and it's nothing more than just some SHA-256 hashing going on in the browser. And so anything can be, any string input can be the input to a hash. And you see, as I type, it's hashing it out and it's creating this signature on the bottom. And that is a unique signature. Some people call it like a fingerprint of the text that you send into it. And that text can be any length whatsoever. And the result is always the same length. So and when you have the results of this hashing, you can't go backwards. You can't go backwards and get this information out of it, but you can easily put this information into it. Like here, if I Wisconsin.net meetup. So if anyone else types this, including case sensitivity, into their web page, they're going to get this exact same hash coming out of it. So it's deterministic based on what you put into it. So that's one of the main building blocks. So that leads us to a blockchain. So a blockchain is what it sounds like. It's a chain of blocks. What is a block? A block is nothing more than a OCO. So it's just a plain old object, bag of data. So the data can be one property of the object, and then you have the previous hash, the current hash, an index, and a timestamp. And all of that together is considered one block. And so the chain of blocks comes in with multiple instances of that, and then they refer to each other. So the hash from the previous block goes into the field of previous hash in the next block. And that is where you get the chain from, because they're chain linked together. And what that gets you is that no data can ever be changed in history. So if I go back into the data that was loaded into the first block and I change it, that's going to change what the hash would be for that block, which would change what the previous hash was for that block, which would change what this hash is. And so basically, the chain cannot be corrupted. And so this has been around for a while. I would guess most people know about this conceptually. And that is the foundation. So I want to pause here for 1 second. So I threw together a quick C# code demo of a blockchain in action. I was preparing to code that live, or I could just show you the code and run it. So if anybody's brave enough to come off mute and voice their opinion, then you'll win the day on which way we go on this.
Hey, Kyler, can you talk about the fact that, so that hashing is connected to each one of those blocks, but everybody on the distributed ledger has access to that. So in order to hack the system, you would have to hack every single one of those computers that have access to that distributed ledger. Can you talk about that?
Yes. So that comes in the Bitcoin side of it, where they have a consensus mechanism. And so all of the different computers, or miners, as they call them, vote on the consensus. And in order for you to cheat, you would have to control 51% of the miners, and that's like the 51% attack, which is an astronomical amount of computing power that no single country could even wield at this point. And so the data on the chain, by way of a voting consensus amongst all of the miners, Bitcoin miners, protect that data. So it is basically, it's immutable, meaning it can't change over time and no one can hack into it without corrupting the entire chain. And it's also tamper resistant, bordering on tamper proof, in the sense that you would have to have more, at least 51% of the hashing power, computing power across the whole globe.
So you'd have to hack all of those hashes, and then you'd have to hack all of the other distributed ledgers that have those hashes, correct?
Yes. Yes. And by hacking the hash, it's a little misleading. Like, you wouldn't have to, because a hash is cryptography, and you wouldn't have to somehow break cryptography for it. What you would have to do is just, you would have to have so much computing power that you could vote your change to the data into the system. And so, for example, on Bitcoin, it may say that I have 1 Bitcoin and I pay Matt that Bitcoin. Well, it has to ensure that I have a Bitcoin in the first place, right? Before it will let me pay Matt. Well, that's what the miner does. The miner says, yep, it goes through all the blocks and it says, yep, Kyler has 1 Bitcoin that he can use to pay Matt. That miner could cheat and say, Kyler's actually paying Matt 1,000 Bitcoin, even though he only has 1. And he could write that data to the block. But in order for that block to be accepted, it would have to be voted as truth by 51% or more of the miners in the consensus algorithm. So in order to do that, you'd have to have 51% or more of the total computing power across the globe of miners. So hope that makes some more sense. Anyone have a vote on seeing C# code for a blockchain, seeing that running in a Blazor app?
I'd be interested in seeing a demo of it.
Okay.
I'd second that.
All right, so then I won't code it, but it's so simple. I created it very quickly based on an article online, which is fantastic, which I'll reference later. But just a POCO object for a block. And as we talked about, you've got the data in the block. You've got a string for the previous hash, an index number, because every block gets a unique index number that just increments, a timestamp, and then whatever the current hash is. And so when you create a new block, you just pass in data, and then you pass in the previous hash, set those properties, and the index originally starts off as 0, and the timestamp gets stamped with now. And then the new hash just uses a simple function called calculate hash. And that's where we get our SHA-256 cryptography algorithm. And we say, take the input bytes, which in this case, we're going to include in the input the timestamp, the previous hash, and the data. And then we will let the cryptography compute that hash number, same as the JavaScript did in that web app. And then we'll return those base 64 encoded results. So that's a block. And then the chain is nothing more than a list of blocks. And we initialize it by creating a new list of blocks. And then we add the genesis block, which is just the first block, the very first block in the chain. And we could throw in some data, whatever string we want. So data is just nothing more than a string. In Bitcoin, Satoshi opted for the data to be a ledger. So it's just Kyler pays Matt and how much. But it really could be in a blockchain, it can really just be anything. So we just throw a random string here. And then the previous hash is just the empty string there, because there is no previous hash for the first block. And then we just have a convenience method for getting the most recent block, and then a method where we add a block. And so adding the block, we'll just say, go get me the last one in the chain. Now make this new block that I'm about to add, increment the index from 1 from the last one. And then whatever the latest block's hash code is, set that equal to the new block's previous hash. Calculate the new hash for the current block based on those 3 data point inputs of the timestamp, the previous hash, and the data. And then just add that to the list. So create a quick Blazor app for this. Just run that real fast and you can get a feel for it. And so some new data, we'll add that. And so we get the genesis block that has that hash, and then the new block that has the previous hash, and then the new hash. And so we could say, it could be JSON, it could be a payment of, let's say, amount equals 1 and from is Kyler, 2 is Matt, and add that as a block to the chain. That's really all it is. Any questions on that?
We do have a question in the chat, and it's, can quantum computing crack this?
There's a white paper by Deloitte Consulting that goes in depth on that topic, and I don't recall the details to it, but it was not a, it does break part of this, but there are researchers working on, there's already a proposed quantum tamper resistant encryption and therefore blockchain. And so there could be in the future a quantum version of all of this. But no, it doesn't break it. Like, you won't lose all of your money on the blockchain. But if you, I think it was something like, if you reuse the same wallet address, then that is maybe where there starts to become a problem. It is an interesting question, maybe a topic for a future presentation. All right, so we've talked about a blockchain, but now getting a little bit more detailed into opening up Satoshi's mind on how he invented this thing called Bitcoin. And you can see that this is the same thing, but there's one added property called a nonce, and that's just short for a number used only once. We'll talk about what that is. And so a miner would have a copy of the entire Bitcoin blockchain, and there are hundreds of thousands of miners across the globe. And so those miners, so Satoshi said, all right, the data in the block shall now be, should be a ledger of payments, just like we kind of mocked up. And miners shall search for new nonces that comply with the difficulty requirement. And we'll do a fun demo of that in a second. When they find, so they are looking for nonces that solve the problem. And when they find one, they validate the payments. So making sure that Kyler has 1 Bitcoin to pay Matt. And then they create that block. And the reward for them doing so and looking for those new nonces is they get paid in Bitcoin. So today, every 10 minutes on average, a new nonce is discovered, and the miner who discovers it gets 6.25 Bitcoin, which is somewhere in the neighborhood of like $300,000. So let's do another demo. So if you go to, let me see, so go to this first URL or snap it with your phone. And that will bring you here. And so this is just a slight derivation, a slight addition to what we did before. So this is a mock miner. And if I'm going to search for a nonce, and a nonce is just a number, and if I type in this number and I say hash, then it gets a hash result, which is this number right here. So this is the hash. So what we're doing is, in addition to hashing based on the timestamp and the previous hash and the data, we're also hashing with the nonce. And the nonce is the thing that'll change. And these Bitcoin mining machines search trillions, literally trillions of numbers per second. And all they're doing is just calculating the SHA-256 hash trillions of times a second. And so they may try the number 1 and it results in this hash. And then they go, nope, that's not it. They try number 2. results in this hash, number 3, and they keep going. Their goal is to create a hash, and this is the Satoshi innovation. Their goal is to result in this hash that has a certain number of zeros at the beginning. So he just said, you know, we need this to change its difficulty level, and so we will look for a hash that is less than, in this case, it's this number. So if you can, you know, hex is just a number, just in a base 16 representation. And so this is a really large number because it's got an F way up here. So this is a gigantically large number. And so it should be pretty easy if we just keep trying different numbers. And if you guys have this up and you get one, then please come off mute and let me know. And tell me what that nonce is. Ah, there we go. Okay, 39. So the hash that I generated with the number 39, and if you have the same web page up, you can type in 39 and you'll get the confetti. The hash that it generated was 0B. Well, that's less than 0F. To start off with, in this, if you consider this a gigantic number. So my hand miner has just mined a new nonce, and so I can create a new block and I get rewarded with $300,000. And a new block gets committed to the chain. So that's really how it works. And again, jump in if you have any questions, but if not, we'll roll on. So that gets us up through Bitcoin. But how about Ethereum? So Vitalik Buterin was the inventor of Ethereum. And he took Satoshi's concepts, read the white paper, and said, that's really great, but I think we could extend it further. So instead of the data being just ledger payment values, he said, what if we allow programs to be stored in the data itself? In fact, what if we could make those programs Turing complete so that they can represent any logic possible?
So I had a quick question or comment. I don't know if you can hear me.
Yep.
So I think that's where the quantum computing actually is, that's where the blockchain becomes vulnerable from the quantum computing, is that hash calculation. Because right now it's set up to be a 10-minute cycle, but technically a quantum computer could calculate that new nuance much faster. Like in a fraction of the time. So I think that's what the challenge is. That's what they're trying to solve. Not really cracking the hashes, just, you know, so that someone can't come in and suddenly start generating blocks every 30 seconds with a quantum computer. I
think I do know that quantum computers could calculate a hash very quickly and calculate, you know, quintillions of them probably per second once they mature with enough qubits. But I think quantum computers are actually a threat to reversing the one-way function of a hash itself. Like, to some degree, you can't. I mean, my impression is that it's a prime number factorization, and you have to try so many combinations that it would take you more time than the universe has been around in order to go backwards. But the quantum computer, because of the qubits, can actually potentially
well, it can't really, nothing can really crack a hash, because the way if you look at the cryptography formulas, it actually is a reducer. So you can't get the original number from, it's like you're taking the original number and you're dividing it by 12, and then you're subtracting 10, and then you can't get to the original number. But what a quantum computer can do is since it knows it knows all the other data in the blockchain, it can kind of try to calculate the hash much faster, basically. Because the hash is irreversible, because it's basically it uses what's called a negative so it basically it removes data. So it's really one way. You know, it's like there's the data is not there to get it back the other way. But what you can do is by, you know, because if you think about how long it takes calculating the hash is that, you know, if that can be sped up, like I said, with the nuance, it's just going through those numbers. Well, a quantum computer can just fly through those numbers and be generating those hashes at a much faster rate than anything out there today. You know, and that's where because reversing a hash is, as long as it's a high enough encryption level, it's not going to happen. I mean, obviously, weak caches have more vulnerability, like 128s and lowers, and they've actually keep raising the number of bits in the hash to try to, you know, to fight the hacks. That's why you have like SHA-256. You know, if you read like SHA-1 and SHA-2, which were earlier encryption schemes, are now hackable because they weren't using enough data in there to generate the number. So that's it gets much more deeper into the whole world of cryptography and the whole hashing works. But yeah.
All right, Ken, you're queued up for a quantum presentation next.
Well, there's one here. I'm in Chicago, but there's the ACM Chicago is actually going to have a presentation on quantum computing tomorrow online. So
very nice. So the miners in this case, in addition to going back through and saying, does Kyler have enough currency, because it's Ethereum now, not Bitcoin, but does Kyler have enough currency to pay Matt? They also will execute programs. And so those programs are called smart contracts, and they are just programs. They are just, in fact, they're just a collection of methods, and those methods have parameters, and then there's data that can be stored on the blockchain, like variable values. And so those methods can change the value of those variables. And smart contracts can also refer to any other smart contract on the entire Ethereum chain, or refer to any data on Ethereum. One other thing to note is everything that we've talked about is when they say it's pseudonymous or pseudo-anonymous, but also public. So all of these chains are indeed truly just public. Like anyone can see the entire blockchain. You could run a node and you could look at the entire thing. You see a bunch of wallet addresses, and you don't know who owns those wallet addresses until some sort of in real life link is made to those. But you can see, you know, hackers, you can trace their transactions and follow them down the rabbit hole. So I thought it might be helpful if we actually view a smart contract. So this is a website called Etherscan, and they have an Ethereum node, and they watch all of these transactions, blocks that get committed to Ethereum, and then they throw them into a relational database, and they add some web services that people can access, and they throw a web UI on the front end of it. And so this 30 seconds ago was a transaction that just got committed to the Ethereum blockchain. And it was, oh, that's a lot. Oh, maybe not. So this is some transaction happening. This is for a particular token called Shiba Inu, which is like a meme. You know, people have probably heard of Dogecoin, which is just a meme token. And Shiba Inu is like a meme of a meme. And yet its market cap is in the billions, which is just a crazy thing. But here are transactions that are happening right now for that smart contract. And you can even see, let's see, you can see the contract itself, and you can actually go look at, you can look at the code. The code is written in a language called Solidity, and it looks a little bit like C, not too far from C#. It's pretty simple, easy to understand. And those, you can go look at any of these. So there's financial instruments, DeFi, that we'll get into, and you can actually go look at any of those chains, look at all the transactions, look at all the value passing between them. All right, so That's great, but how does one actually write an application using any of this stuff? So this is a diagram showing the typical web architecture that we all know. And you have, at least in a single page application, the browser requests content from the web server, and the web server returns static content like in the form of HTML, CSS, and JavaScript. And then that JavaScript can send in requests, like REST requests, back to the web server, which processes it and returns data. Well, in this potential new world, you have this. Can you see? I can't tell if the controls are blocking the screen or not. Okay. So in this new world, you have an Ethereum node, and that has the chain of blocks, and that is really like a virtual machine that runs. So when those miners mine new blocks and they execute the code, you can consider that a virtual machine, and that have smart contracts and wallets. So the way that you can write an app to access those is using a hot wallet, and the most popular one is called MetaMask, and that's just a Chrome plugin that stores your private keys so that you can sign transactions. You can prove that you own a particular wallet. And so you have that MetaMask plugin, and you still have static content, the browser requesting static content from your web server. And that static content can include JavaScript, notably something called Ether.js or Web3.js, or JavaScript libraries that know how to talk to the Ethereum virtual machine. So your app makes requests. This time it goes to an Ethereum node, and then that executes code and returns data. If you want to, you can even, so at that point, right, you don't need your DB or your business logic here. That you can think of the blockchain as sort of a database, and those smart contracts can have business logic in them. So that portion of your web server can go away. And if you want to, there's even distributed file stores. There's something called interplanetary file system, IPFS, that stores files distributed across hundreds of thousands of machines, sort of like a distributed torrent, if you know what that is. And so that could even, that could serve up your static content. And at that point, your web server can go away. You don't need Azure, AWS, whatever. At that point, you have what's known as a pure distributed application, or DApp. In reality, this is not a common architecture because space on the blockchain is very expensive. You want to minimize the number of variables that you store on chain. You want to minimize the amount of business logic that gets executed because it's really expensive to execute it and to store it. And so in reality, it's really a hybrid structure. You still have your web server, you've got all your business logic, you got your relational database, but anytime you need to transfer value from one person to another, or you need to execute some sort of high value transaction that's on chain, then you would do this. So here's a good example of a DApp. It's called Zapper, zapper.fi. And you can connect to it. And so here's my MetaMask icon in the upper right, the Chrome extension. You click on that, and it will authenticate you to this JavaScript. At this point, it's just like a client-side app. And then that client-side app connects into Ethereum, pulls back data for the wallet that you just signed to show that you own it. And then it can pull data values from it. This is an example. If you click on MetaMask, what it looks like. So it'd say, yeah, I'm using the Ethereum mainnet. I've got an account that is a wallet address, and I've got 0 Ethereum in it. It could also have things like Shiba Inu tokens or Dogecoin, whatever. I think I'm going to skip this part unless somebody jumps in and wants to see it. But there's an open source library out there that will wrap some of the JavaScript like Ether.js in the C# code, and also have MetaMask JavaScript in there that can talk to MetaMask, and maybe I'll show it just real quickly. Actually, I'm going to skip that. I think we're, hey, Jason, can you give me, I've completely lost track of time. You want to give me a feel for how much time we have?
We started a little bit late, so we've got till, well, 6:30.
Till 6:30, okay.
Yeah.
All right. So let's jump back into slides. Anyway, if you search for Ethereum with an N before it, GitHub, MetaMask, Blazor, you'll find an open source project out there that you can clone and spin up, and it shows you that. Is anyone interested in seeing that? Happy to show it.
I'm actually interested in that as well.
Okay. Let me. So it looks like a large project. There's not really that much to it. It's just got a couple different versions of it, like the WASM version versus the Blazor server version. Let me just run it. You can see what it looks like. All right, so the starting template that we all know, and it says, please connect to Ethereum. And normally this would say connect, but it can detect that I don't have the MetaMask wallet installed. And so that's just in that session, I believe. So if I go here, run the same app, now it says, instead it says connect to MetaMask. So clicking on that will open up MetaMask. All right, so we'll connect in, and now MetaMask is connecting my wallet address to this website. And so it says, here's my wallet address. And if we wanted to, we could even go look that up on Etherscan, type in any wallet address or any transaction identifier, and it will find it. It'd be more interesting if I had some data there, but this is a different wallet than what I normally use. And you can do a number of things. So if you have heard of an ERC20, we did a typo there, but it's an ERC20 token. That basically means on Ethereum, anyone can create their own token. It is a simple matter of cloning a Solidity contract and deploying it out to the blockchain. And now you can have your own coin. So we can call it Cashier coin. And the ERC20 is a specification that is really just an interface. So it says that if you want to consider your smart contract an ERC20 token, then it should support these 7 methods with each of these individual parameters. And that's, that's the definition of an interface. And so an ERC20 token is just a smart contract that complies to a specific interface definition. And what I can do is I can call that right here. I can say, I want to pay this smart contract address, or maybe that's the from, I'm not sure. Oh yeah, that is the from. And so I could pay, that's Kyler's wallet address. I could pay Matt because he's A instead of F or something. So I can pay Matt, and then I can pay him 1 ETH and click submit. And it would reject this transaction because I don't have 1 ETH in this wallet. But all the tools are here, and there's no, other than serving up the static content from the C# solution, there's nothing, there's no server needed. There's no Azure or anything. It can connect directly to an Ethereum node. So I am not going to focus on the Ethereum technical details. I do know a little bit about it from integrating it with my business, but what I want to talk about next is the value proposition of Web3 and some of the craziness that's been developing out of this. That's what we'll spend the rest of the time on. So first, a couple TLAs or FLAs in one case, but so an ERC is an Ethereum request for comment. So the 20th request for comment turned out to be the spec for tokens that you want to issue. NFTs, if you are familiar with those, was ERC 721. So it's an open foundation where there's open discussion and debate about what enhancements should be made, and the token spec was one of them. DeFi stands for Decentralized Finance, and we're going to have a slide on each of these. ENS is the Ethereum naming service, and DAOs are decentralized autonomous organizations, and NFTs are non-fungible tokens. So these are some. I didn't include on here metaverse. That's obviously a popular one, but that's just so new that I'm not really all that familiar with it. But these are some of the things that are coming out of this technology. So DeFi, this is very much a rabbit hole. This is the rabbit hole I went down a year ago. So because you have Ethereum or one of its competitors, because there are several competitors out there with different value propositions, Ethereum is called a layer 1 chain, and there are several other layer 1 chains. But they all have similar underpinnings that allow you to execute logic, and they're Turing complete. So because of that, anything that you can write in logic can execute on the chain. So an example of that might be, let's say, an insurance contract. So I'm a farmer, and I want insurance for my crops, and I want so I buy into this smart contract, and I pay them some of my ETH in order to be a member of this insurance policy. And anytime there's a drought in my zip code, I get a payout. And so that is just business logic, and that can be written as a smart contract, and that can execute autonomously. It's unstoppable. There's no central insurance agency. There's no administration loophole. There's no delay in the payout. It can all happen completely on chain. So that's sort of the hello world of an application in that space. Any questions on that? Comments?
Think about the deed transfer of a home. Could that happen on the blockchain?
Yes, I believe that it will take a lot of time because the government's involved, but all auto and home deeds will eventually be on a blockchain. And so, yes, and there are some cases of real world things. Like, this is not just cyberland. These things are getting tied to real world things that we'll talk about, but that's a great example. A permanent public record of who owns what and when that cannot be tampered with.
With no central authority.
Exactly, yes. So financial services are a big one. They have exploded recently. In the past, 2020 was called the summer of DeFi, and so one of those cases, I don't remember. I'm just going to go through all these because I don't remember what I put here. So financial services with no middleman. If you think about the total market cap of Wells Fargo and Bank of America and Chase, and it's I don't even know what that would be, but it's a very large number. If portions of what they do can be boiled down to business logic that can transfer value, then it can go on the blockchain, and all of that efficiency gains can be realized by the participants of the network. So there's a popular podcast called Unbanked, where they talk about how do you use these tools to become your own bank, and you really can do this. Like, you can store as much money as you want in your wallet, in your virtual wallet, and you can do lots of traditional financial things. For example, a decentralized exchange or a DEX. That is an exchange marketplace. So basically the decentralized version of the NASDAQ or the NYSE. And if I want to swap, I'm bullish, I'm very much not, but if I were bullish on Shiba Inu and I wanted to swap my ETH for Shiba Inu, then I can go to one of these exchanges, which are just smart contracts, and I can swap my ETH for someone else's Shiba. Another important building block in this space are stable coins, and what that is fiat, currency that countries issue. That is where you have a sort of a crypto IOU for it. So USDC or USD Circle was one of the original, not the original, but one of the original stable coins, and they had this idea where they said, if you pay us you send us $1,000, you're not paying them, they're just like a bank. You send us $1,000, we'll put that $1,000 into the bank, and then we will issue you 1,000 tokens that are all vouchers for your $1,000. Why does that matter? Well, that becomes the liquidity in this virtual world. Because we don't have a United States sponsored digital currency that can flow on these rails, stablecoins have come in to fill in that gap. And so they create tremendous amount of liquidity in the DeFi space. And because of that, they are valuable and they can earn interest. And so this is what led me down the rabbit holes. I discovered that stablecoins through an institution like BlockFi or not Coinbase, but BlockFi and several others, you can earn 8%, even 12% interest on something that is backed by a US dollar. So it's not vulnerable to the volatility of crypto. There are some risks to it, as you would expect for getting 8% versus 0.5%. The risks are that the contract could have been written wrong. There could be a bug in it, or the risk that that group that took my $1,000 didn't actually put it in the bank, but they went and spent it. Then that would kill the pegging of the stablecoin and threaten my assets. But at this point, if you spread out your money across several of these, I think it's a pretty good investment. Another one is over collateralized loans. So you can take out a loan, and you can give loans. So you can be the bank. You can issue a loan to someone else on the blockchain and have almost zero counterparty risk. How is that possible? Especially when you don't even know who's getting the loan. And in this case, you don't. You just create something. You just say, I will loan out my one ETH to anyone who wants to borrow it. Well, if you don't know who they are, how do you know how much of a risk they are? Well, the answer is it's an over collateralized loan. So in order for them to borrow an ETH, they have to lock into the smart contract 1.2 ETH. And if the price of ETH suddenly tanks, then that or they don't pay me back the interest, then the smart contract will automatically send me their collateral. And all of that executes, just like everything else, unstoppable, untamperable. Like that person can't make friends with someone at the bank and get them to give them their money back when they have defaulted on their end of the bargain. So this is logic that's executing, and those over collateralized loans can be pretty lucrative as well. I mentioned before that these smart contracts can refer to any other smart contract, and so what this creates is stackable sort of Lego pieces, financial instruments that are stackable Lego pieces. So anyone in the world can create a financial instrument, and anyone in the world can invest in that financial instrument. So things that used to be the domain, so certainly loaning out money is something that was in the realm of banks, and now users of the network can realize all of that value that previously was wrapped up inside of a central institution. Access to some of these sophisticated stacked financial instruments are things that were only in the domain of hedge funds or accredited investors. So we were gated off. The mass of the world did not have access to such things and did not realize the risk or the reward. But now with these tools, all of this is possible. Yeah. So I'll end this slide by showing a website that tracks the total value locked, or TVL, and that basically means money that is locked into smart contracts. And almost 2 years ago today, the total amount was $1 billion, and today it's $208 billion, and yesterday it was 200. I just checked yesterday, and then today it was $208 billion. So this is all totally transparent. Not to mention, when who is the bank that in the 2008 financial crisis that crashed? Like no one knew what a complicated rat's nest of financial instruments they had created and what the risk
Lehman Brothers
and liability. Thank you. So Lehman, no one had any idea how much risk was on their books. In this world, it could be much more complicated because anyone can create these instruments, and there could be bugs in those smart contracts, but it's all transparent. Anyone with the knowledge to interrogate these contracts can go see it, can go interrogate it and say, what if the price of Bitcoin dropped by half or Ethereum dropped by half? What would be the impact of that? What would be the liquidations of that? What would be the transfer? So DeFi is huge. All right. And any questions or comments? All right. ENS is something much smaller, but easily grokked. It is an alias just like DNS. DNS is an alias from a domain name to an IP address. ENS is an alias from an ETH name to an ETH wallet address. This wallet address can also become your decentralized, and there are people working on this right now to turn it into a decentralized identity and single sign-on, where they're going to throw something like an OAuth 2 flow on top of your ENS name, and ENS is just the smart contract that runs on Ethereum, and the data that it stores is just the name and then what that points to, and it ensures that the name is unique. So just like DNS. It also has additional data points in it, and this is evolving where you can, in addition to saying that Kyler.eth is equal to this address 0x234978, it can say Kyler.eth also has the Twitter handle of Baloo Devil and has the Facebook ID of whatever. So it can, and is sort of evolving into a record that links other accounts. And it's not something that Google Authentication owns, or Azure AD, or Facebook, or whatever. It's not a centralized entity. It's decentralized. An example, so if you're wondering if you're late to the game, yeah, you kind of are. Paris Hilton already has her ETH address, and she uses that as her Twitter name. And the same thing is happening, that the land grab that happened for .com addresses is happening now for ETH addresses. Any questions there? DAOs are decentralized autonomous organizations. And what they are is, because you have business logic on chain, you can create structures, smart contracts out there that are very sophisticated and have logic around voting. So some tokens will have their financial mechanics. So where this started out was some people who had created tokens had design decisions to make, or decisions on how much interest to pay, which part, and what the inflation rate of the token would be, what the burn rate would be. Those decisions, they also wanted to be decentralized. And so they said, everyone who owns a token, for every token you own, you shall have one vote. And so your ownership determines your voting power on this. And we will vote on chain. So by signaling, by calling a particular smart contract with a particular parameter, you are casting your vote, and it's a public ledger or public data, so anyone can see it. So it has evolved into, you can have an entire organization that are decentralized. There doesn't have to be a corporation at their head or an LLC. It can be a group of people that have a shared desire or a shared mission, and they want to cooperate and work together. And now they have the tools to do that. This is a quickly evolving space. The tools are evolving very quickly, and there are a lot of startup businesses that are building out those tools. But it's a fascinating concept. One example of this you might have heard about was the Constitution Dao. This was a group that in 1 week. In 1 week, they went from an idea to raising $40 million. And their idea was they wanted to buy a copy of the United States Constitution that was coming up for auction at Sotheby's. And they lost to a hedge fund manager, which is a real sticking point for people in this space, because there's a lot of energy behind all of this, and a lot of the energy has an anti-venture capital feel to it, or sort of anti-establishment feel to it. So the fact that the Constitution Dao lost the bidding war to a hedge fund manager was a particular pain point. But it's just an example of how people that have no association with each other, they don't need to get to know each other over 6 months and trust each other and ensure that the money is going to go to the right place. They look at the smart contract. Of course, there is a certain element of trust that is required, because for that money to actually be transferred, instead of someone running off with it, you do have to trust a group of people. But if that is established and those people are doxed, as they say, which means you know who they are in real life, then investing in it is nothing more than opening up your MetaMask wallet, going to a website and signing a transaction and sending them your money. So fascinating thing that's evolving. Yeah, another popular use case for this is shared investment clubs. So Raoul Powell, a great thinker in the macro space, former Goldman guy who talks a lot about DeFi, that thinks that this is really where the value is in DAOs, is investment groups where the decisions are governed by the wisdom of the masses, and so these are perfect tools for that. All right, NFTs. I would imagine after the Super Bowl, everyone's heard of NFTs. But if you've not, they are non-fungible tokens. So Bitcoin and ETH, those are fungible tokens. In other words, your ETH is no different. Your one ETH is no different than my one ETH. They're exchangeable for each other. whereas non-fungible tokens are unique, globally unique. And really what they are, they're a proof of ownership of an asset. And this is not just a digital asset. As someone mentioned before, this can be real world assets as well. After kind of watching this from the sidelines, what I see, this is an example. So this, if you're wondering if you're late again on this, you are. This picture is called a Bored Ape, which is one of the original NFT projects. And this picture was purchased by Jimmy Fallon. I don't know how much he bought it for, but these are going for, and I can show you the website, they're going for around $310,000 per picture now. So there are only 10,000 of them. They're all somewhat unique, or they're all unique, but they all look very similar, just with a few little tweaks, attributes here and there. And to be an owner of one of these is prestigious, and so people like Jimmy Fallon have gotten in this game and bought them. Doesn't have to be just pictures though, it can be like music, songs, whatever. My observation from NFTs is really they're about three things. They're about tribe. So when I join a Twitter space and I look at all the profile pics, I can quickly tell at least something about the people there. If I see that they all have NFTs as their profile picture, then that tells me that there's a certain baseline of knowledge of Web3. But there are people gathering around, like everyone rallies together. This decentralized group rallies together and they sort of create their own tribe. And that could be a tribe focused on some humanitarian goal in real life, or it could be some sort of code project. And they say, we want everyone to buy. We're only going to release 1,000 of these images, and everyone needs who wants to be a part of it needs to buy one, and then they use that money to help fund the project. And so it becomes a new funding mechanism too. Second thing is flex. If you Google Lamborghini Bored Ape meme, you'll see a lot of funny stuff. Someone who sold his Lamborghini in order to buy an ape, but it's flexing. And then third is the collectability, baseball cards of yore. And certain NFT collections have rarity factors. So, you know, the Jimmy Fallon one having heart sunglasses, there may only be 5 other apes that have heart sunglasses. And so this one could be ranked with a certain level of rarity. And so it might be worth more than the others. Also seeing this pop up as functionally as community gating. So there are some Discord channels that in order to participate in the Discord channel, and that's just like Slack or Teams, in order to actually participate in it, you have to show that you have one of their NFTs, and there's software that enforces that. Also in real life, or IRL as the kids say, there's someone named Gary V who's opening up a restaurant, and in order to eat at that restaurant, you have to own one of his NFTs. If there's anything else I want to say about that. Also, it's also taking over, like there's something called a POAP, a proof of attendance protocol, which is basically just an NFT. It is just an NFT, but it's given out to people at an event. So it used to be you go to a concert, you buy the t-shirt, you wear the t-shirt to show people that you were there. Now you can own an NFT and you can show people in the online world that you were there. So the Super Bowl, the NFL partnered with Ticketmaster and Dapper Labs to release an NFT to all Super Bowl ticket holders, the first one. So those are viewable on chain, they're tradable. You can look at how much they cost. You can buy one off of one of the original owners. And then lastly, and this kind of gets into the metaverse, but is gaming. So tons of opportunity for using this technology for gaming. Kids buy Fortnite usernames and passwords because that profile has one of the original skins or avatars. So if you think about what if that was the only person on Earth who had that particular avatar, and you could trade that avatar how much would that be worth? And so this is just obvious writing on the wall that this is coming in a big way into the gaming space, and we'll hear more about that. All right, so wrapping up, so Web3 is a new way of thinking about products and software. It's also a new monetary system and source of funding. And some current day Web 2 companies that have all of this value accrued through their network could potentially be displaced by this. So looking at some of those examples. So YouTube has a decentralized alternative called Odyssey, and these decentralized alternatives you may never hear about them. There's a whole lot to execution. So just because they're out there doesn't mean they're going to obviously take over these massive organizations. But just to give you a flavor for the concepts, there are companies springing up that have built systems on top of Web3 that allow you to do very similar things to some of the network effects. Well, no one would ever consider trying to replace YouTube, or at least that'd be a poor effort, because YouTube has all the content. Same thing for like LinkedIn. No one is going to be successful creating a LinkedIn replacement because everybody's already on LinkedIn. But what if you were starting one of these companies and you said, all right, we have a token, and the first 10,000 people to join the network will get 10,000 of these tokens each. Those tokens are initially worthless. Like, we just created them. Like I could have just created my own ERC20 token, and I could create a bajillion of them. And so I can give those out to people. But then you say, all right, the next wave, the first 1,000,000 people will now get 1,000 of these tokens. And then the first 5 million will get 100 of these tokens. As more people join the system and contribute to it and play along and contribute data, that's creating value. And so the value can potentially disrupt some of these companies that have built tremendous centralized value. There is actually a path to creating network effects, and having the people who use the network realize the value. So on Reddit or on Yelp or on Amazon, instead of leaving reviews that earn you fake points, what if those actually earned you points that had a monetary value? Well, that's the future, and that's what Web3 is going to bring to us. All right, that is the last, almost last slide. So yeah, so this is growing quickly. This is Raoul Powell. He talked about the pace of crypto is growing twice as fast, or 100% as fast, 113% in terms of users as the internet was. I don't know this particular quote. I've heard him say like it's growing basically twice as fast as the internet was in 1997. So tremendous value going into this, still tons of potential. You are very early, but it's also fraught with potential hurdles. So you've probably heard of some of the scams that have taken place, and it is the Wild West. If you send money to an address that doesn't exist, you have lost that money. There's no help desk to call. There's no recourse. There are some things like insurance companies that will insure some of the stuff that you do on chain in case you screw up or in case it's hacked. But it is the Wild West, and people are losing money. They're also making money. Or the smart contract could have a bug in it, or it could even have malicious code in it. There are ways to protect yourself against that, like Etherscan. You can go view the Solidity code, and if it has a check mark next to it, you are guaranteed that that is the actual Solidity code. And so if you know enough to look for some of the exploits, then you could sort of sanity check that smart contract. So tons of potential, also some roadblocks. So finally, Web3, many a thing, no intermediaries, decentralized, easy transfer of value, programmable money, and shared ownership. A couple of resources for you, the Andreessen Horowitz Crypto Startup School, if you're interested in starting a business in this space. Highly recommend those series of videos. If you want to learn smart contract writing, then DApp University on YouTube is a great one. And then finally, just a plug for me and what I'm doing. I'm here presenting because I'm looking for collaborators on my business. I'd be happy to share more about my business, but it is in this space. I'm a seasoned entrepreneur with a few successes and failures under my belt. I am writing it in C#. And so I'm looking for people that are interested in helping out. I can be reached at Baloo Devil on Twitter or Kyler Nunery at getcashier.com. And that is all I have.